Let's go to page 335, and this is lesson 5.6. And this lesson is about inequalities in two triangles and indirect proof. It says, imagine a gate between fence posts A and B, okay, that has a hinge at A and swing open at B. As the gate swing open, you can think of triangle ABC, which with side AC formed by the gate itself. So think about this triangle over here. So you got triangle ABC, okay? The side AB represents the distance between the fence posts. Okay, so that's the opening. The side BC represents the opening between the post B and the outer edge of the gate. So you can see as you open, you increase the angle A. Okay, as you increase the angle A, notice the length of BC it gets bigger, right? So bigger the angle, the opening, the distance, the BC gets bigger. And notice the AB and AC stay the same. Okay? So only thing changes is the angle A. So once the angle A change, it also changes the BC, the length of BC. Okay? So it says, notice that as the gate opens wider, both the measure of angle A and the distance CB increase. This suggests the hinge theorem. Okay? I can think about this scenario over here. Okay, so again, think about the gate is hinged over here. Okay, so here's a theorem. Okay, so theorem 5.13, the hinge theorem. It says if two sides of one triangle are congruent. So you can see if the two sides, so that in this case, like AB and AC are congruent, right? AB and AC are always congruent. So if two sides of one triangle are congruent to two sides of another triangle, so you can the AB and AC, AB and AC, AB and AC all congruent, right? Okay. And the included angle of the first is larger than the included angle of the second. So if the included angle, the angle over here, is bigger than this one, then the third side of the first is longer than the third side of the second. So what it's saying is that, okay, so you got AB and AC are all same. So as the included angle, the angle A it get bigger, the opposite side becomes longer. Okay, see that? So you can see that. So again, as the angle, the included angle gets bigger, the opposite side becomes longer. Okay, so that's what it's saying. Okay. Now this one is the converse. The converse says that again, if the two sides are fixed, okay, and if the third side gets longer, that means that the included angle gets bigger. Okay. Again, converse. If two sides of one triangle are congruent to two sides of another triangle, okay. So again, over here would be like this is like the door, and this is like the opening, okay. And then as the door swing, as the door close, the distance get closer, okay. So again, if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So what it's saying is again, okay, it's sometimes very confusing if you just read it, but what it's saying is that again, if the two sides are congruent, okay, and the third side, if the third side is bigger than the third side of the other, that means angle is bigger, okay. Just look at the opening. So this is, whenever you get confused, always go back to this example over here, okay. So again, you got two sides are fixed. So AB is the opening and AC is the gate. So opening the gate, right? Now the distance, okay, the distance, right? So the distance get bigger, then the angle gets bigger, okay, and vice versa. If the angles gets bigger, then the length getting longer, right? So that's what it's saying, okay. So again, if you're getting confused, just look at this example, okay. So look at the picture, okay. So the two sides are congruent. Think of as the door and the post between the distance between the two posts. Okay. Again, always go back to this example if you start getting confused. Okay. So this is a congruent side and this is congruent side. The only thing vary is the BC and the angle A. Okay. So again, if the length gets longer, the angles gets bigger. Okay. And vice versa. If the angles gets bigger, the length gets longer. Okay. That's what this is saying. Okay. So it says use the converse of the hinge theorem. Okay. So it says giving that ST is congruent to PR. How does the angle PST compare to, so how does angle PST, this angle over here, compare to angle SPR? So compare these two angles, okay? How do they compare? Well, again, you have to use the hinge theorem, right? So this side and this side are congruent, and when the two triangles butt against each other, use a reflexive. So PS is congruent to PS, so you can mark right over here, okay? So you can use PS congruent to PS by reflexive. Okay, so now you got two sides are congruent to two sides of the other triangle. Now you can see that this angle, the PST, is greater than angle SPR. This angle is bigger than that because this is 24. This is greater than that. So you can, when you have greater length, you're going to have bigger angle, right? Or you can, so this is called the hinge theorem, right? I can just say that the angle, so here it says because 24 inch is greater than 23 inch, okay, therefore the PT is greater than RS, so two sides of the triangle STP are congruent to two sides of the triangle PRS, okay, so again these two sides are congruent to these two sides, and the third side of STP is longer, therefore, okay, by the converse of the hinge theorem, measure of angle PST is greater than measure of angle SPR. Okay. Okay. So now let's go to example 2. Solve a multi-step problem. Okay, biking. The two groups of bikers leave the same camp, heading opposite directions. So over here, so here's the camp. Okay, and they go opposite direction. And each group goes 2 miles. So this one goes 2 miles. See, 2 miles, and this group goes 2 miles. Okay. And then, okay, group A start due east. Okay, group A started due east, and turn 45 degrees. So again, east is this direction. So this go east and turn 45 degrees. Okay. So if this is 45 degrees, okay, then this would be 135 degrees, right? Because that area equal to 180. So you can draw your picture, help you to visualize. Group B due west. So again, you have to know your direction, right? Up is north, so north, east, south, west. So the other group heads south, west for 2 miles, and it turns 30 degrees. So this would be 150 degrees. Now, which group is further from the camp? Explain your reasoning. Okay. So reasoning would be this group would be further from the camp because 150 degree. Okay. So 150 degrees is greater than 135 degrees. So because again using just like the hinge theorem, right? So these two sides are congruent, and these two sides are congruent. So the things that difference would be the angle in between, right? Including angle. So since this angle is bigger than this angle, so this length had to be greater than this length. So the group B is further from the camp, right? So again, solution. Draw a diagram and mark the given measurements. So draw a diagram, mark the given measurements. The distance bike and the distance back to the camp form two triangles. Okay, so bike and go back, right? With congruent 2 mile side, so these two sides are 2 miles are congruent, and the congruent 1.2 mile side. So these two sides are congruent. Add a third side of a triangle to your diagram. So that's your picture. Next, use linear pair to find and mark the included angle of 150 and 135. So again, here's your 45. So you find the angle 30 degree, found at 150, right? Now, because 150 is greater than 135 degrees, so group B is further from the camp by the hinge theorem. Okay. Okay. Now let's go to page 337. Indirect reasoning. Suppose a student look around the cafeteria, conclude that hamburgers are not being served, and explains as follows. At first, I assume that we are having hamburgers because today is Tuesday, and Tuesday is usually hamburger day. Okay. Now you have to be careful. Again, it's usually, right? Okay. And you have to be careful in direct reasoning. Sometimes indirect reasoning may not be true, so be aware of that. There is always ketchup on the table when we have hamburgers. So I looked for ketchup, but I didn't see any. So my assumption that we are having hamburger must be false. Okay. Now one thing I have to be careful is, he didn't see any ketchup. It could be that they just happened at that moment, particular moment, that ketchups run out and they are on the process replenish it. Right. It's possible. Right. Okay, so again, so you have to be careful with indirect reasoning, but most of the time they are okay. Okay, so it says the student used indirect reasoning. So far in this book, you have reasoned directly from giving information to prove desired conclusions. In an indirect proof, you start by making temporary assumption that the desired conclusion is false. By then showing that assumption leads to a logical impossibility, you prove the original statement true by contradiction. So for the indirect reasoning, you have to try to come up with the opposite. And if the opposite is false, then the original must be true. Okay? So it's almost like counter-example. Okay, so key concept. How to write an indirect proof. Step 1, identify the statement you want to prove. Assume temporarily that this statement is false by assuming that its opposite is true. So again, here's the key. Okay, so assume opposite is true. Reason logically until you reach a contradiction. Point out that the desired conclusion must be true because the contradiction proved that the temporary assumption false. Okay, so example 3, write an indirect proof. Write indirect proof that an odd number is not divisible by 4. Okay, so giving x is an odd number, prove x is not divisible by 4. Okay, so solution, step 1, assume temporarily that x is divisible by 4. Okay, this means x divided by 4 equal to a number because divisible, right? Divisible by 4. So x divided by 4 will give you a nice number. For some whole number n, so multiply both sides by 4, give x equal to 4n. Number 2, if x is odd, then by definition, x cannot divide evenly by 2. However, x equal to 4n, so when you x divide by 2 equal to 2n. We know that 2n is a whole number. Because n is a whole number, so x can divide evenly by 2. This contradicts the given statement that x is odd. Therefore, the assumption that x is divisible by 4 must be false, okay, which proves that x is not divisible by 4. Okay, so again, go over this again. Okay, so giving x is a number, is an odd number, you want to prove that it's not divisible. So you want to do the opposite. Okay, assume that the x is divisible by 4. Okay, but by doing that, okay, so x can divide by 4, and therefore x divided by 4 will give you a number, right? That's what I mean by that x is divisible by 4. That means x divided by 4 will give you a nice number. Okay, that's what I mean by this, right? Okay, so again, x divisible by 4 means when you x divided by 4 will give you a nice number. Okay, it says for number of n. So by multiply both sides by 4, the x equal to 4n. But if x equal to 4n, that means it's even because it can divide by 2, right? Because when you divide x by 2, you get 2n. So it means x can divide by 2 evenly, nicely. So that means x has to be an even number, but which contradicts to that, right? Okay, so again, that means it tells you x has to be an even number. Therefore, we know that in order to divide by that 4, one of the conditions is it has to be even. Okay, so if it's odd, then you're not going to be able to divide by 4. Okay, so again, so it takes a while to get used to for indirect proofs. Okay, let's go to example 4. Prove the converse of the hinge theorem. Okay, so write indirect proof of theorem 5.14. So given AB is congruent to DE, so make the marks, okay, and BC is congruent to EF, so make the mark, and the AC is greater than DF, so this length is greater than that. So you want to prove that this angle is bigger than that. Okay, so what you have right now, is you want to prove the converse of the hinge theorem. Okay, so assume temporarily that measure of angle B is not equal to measure angle A, then it follows that either they are equal or less, right? We want to do the opposite, right? We want to do the opposite. So instead of making B greater than E, we want to say that equal or less than, okay? So case 1, let's do it equal. So if angle B is equal to angle E, okay, then, so if the measure angle B is equal to measure angle E, then that means angle B is congruent to angle E. So if these two are congruent, okay, if angle B is congruent to angle E, then we have congruent triangle because it would be SAS, right? So again, if the two angles are congruent, then two triangles will be congruent because of SAS. And if the two triangles are congruent, then we will have the AC is congruent to DF because of CP/CTC, okay? So again, that is kind of contradict, right? Because again, that's why we have, right? AC has to be greater than DF. So if these two are congruent, then these two will be congruent, which contradict to that. So it shows you that this cannot be equal. Okay, again, if these two angles are congruent, then this will be congruent, which is contradict to that. Okay, so cannot. So strike it out. Next, if an angle B, if a measure angle B is less than that, so if this is less than that, then this opening would be less than this, right? From the hinge theorem, right? Again, if this angle is less than that, then this would be less than that, which again contradict that. So it cannot be less than. So if it cannot be equal, and this cannot be equal to that, and this cannot be less than that, then only conclusion is that this must be greater than, the B must be greater than that. Okay? So again, by conclusion, contradict the given statement that AC is greater than DF. So the temporary assumption that measure of angle B not equal to measure of angle E cannot be true. This proves that measure of angle E must be greater than measure angle E.